Hi guys, I'm going to be talking about problems 2 and 3 from the group problems this week. Starting with problem 2, A. For this problem, I got topoisomerase 2 is composed of 4 protein subunits and uses ATP to compact bacterial chromosomes, while a blank, I put nucleosome, contains 146 to 147 base pairs of DNA and 8 histone proteins. B, I got the DNA double helix is 2 nanometers wide. Adjacent base pairs are separated by 0.34 nanometers in the double helix. For C, I put for the blank topoisomerase 1 introduces positive supercoiling into DNA and cuts one DNA strand. D, I put the origin of replication of E. coli is called, I would just pronounce it ORIC. E, put in the Hershey-Chase experiment, bacteriophage T2 proteins were labeled with a radioactive isotope of 35 sulfur, while bacteriophage T2 DNA was labeled with a radioactive isotope of 32P phosphorus. And this is because DNA doesn't contain sulfur, so they can track that with proteins. Proteins don't contain phosphorus, so they can track DNA with that phosphorus isotope. For F, I put the sugar in uridine is ribose, while the sugar in deoxythymidine is deoxyribose. You can just tell that by the prefixes in those names. And the other answers as well can be found by looking at the instructor notes. Moving on to question 3, to part A. It's asking how long is the DNA portion of this translocation chromosome in meters. To calculate this, I added the number of base pairs, 1.09 times 10 to the 8th base pairs plus 4.8 times 10 to the 7th base pairs. Times that by the ratio that we know that brain freeze, is that every 10 base pairs is 3.4 nanometers long. Just calculate this out, you get 5.338 times 10 to the 7th nanometers. Convert that to meters, and it's 0.05338. Question B asking how many nucleosomes are found within this translocation chromosome, assuming that the average length of the linker DNA is 50 base pairs. We know that as we talked about in the previous problem, the nucleosome contains 146 to 147 base pairs of DNA. So we just add 146 and 50 gets 196 base pairs per nucleosome. Just add those up, divide, cross each other out, and you get 801,020 nucleosomes. For part C, we're asked how many H2A molecules would you expect to find within this translocation chromosome? So there's 8 subunit proteins, or there's 4, there's 2 of each, what comes out to 8, so there's going to be 2 H2A molecules per nucleosome. So I just times our previous answer by 2 to get this answer right here, 1,600,000, 2,040 H2A histones. D, we're asked how many radial loop domains would you expect to find within this translocation chromosome. To calculate this, we know that there's 25,000 to 200,000 base pairs per radial loop domain. So I took the total number of base pairs, divided it by 25,000, and then also again by 200,000 to give us a range of 785 to 6,280 radial loop domains. That's not a minus, that's just the dash to show the range. And that's how you do problems 2 and 3.